right, so now we've talked about volume, right? And when this is volume by rotation, we did volume by cross section, right? But we know when we want to find volume, what do we do to do that? Integrate area, right? We are still integrating area, but we are looking at these differently. Still kind of looking at cross sections, but the nice thing is since we're revolving, when you revolve around an axis, you are creating circles. So your revolutions are pretty much always going to be circles. So we can have volumes of disks, one circle, no hole, or volumes of washers, which is two circles, and there's a hole in the middle like a washer. Okay, so, and you can have like, so like this is what a disk would look like, and there's a little bit of thickness, right, because we've got to be able to find the volume. That's your radius. If I have a washer, then it looks like a flying bagel. Yeah, I can't really. So this is your big R, and this is your little r. So the radius of the inside part and the radius of the whole thing. Like a lifesaver, even. Okay. So this capital R is one way to show that it's the radius of the big radius and then the little radius. Another way to write that is to say I have the volume from A to B. This pi here, because the pi is not being squared, it's the r's that are being squared, right? We can factor that all the way out here, pi, and then this can just be big R squared minus little r squared dx. Well, kind of goes with physics. So we're going to sketch, and you are expected to like sketch something and at least get an idea of what the heck is going on. But let me show you some things first. So let's start with, here is a rectangle that we're going to revolve around. So when we revolve that around, you see how it's just a circle? We have a bunch of, there we go, right? Let's stop the revolving. I'm going to reset it. Okay, so now I'm going to move this out here. And then when I revolve it, this is what's going to create a washer, like so. See how that works? Okay, so that's just plain old rectangle, right? Then, we don't want to look at that one. We don't want to look at that one. Okay, we'll look at this one. So here is this region. This is a region that we could find the area of, right? And we are going to, let's see, can I move this? Let's just leave it. We're going to revolve this, and it says axis of revolution. That is the x-axis, so we're going to revolve. You see how it's revolving and it's making a cone, right? And then watch this. See how those are circles? They just get bigger. Okay, so your cross sections are still, they're all circles because I'm revolving. So now will it change our axis of revolution? I'm not sure how to change that. I don't think I'm going to be able to do that. I can't. Nothing will move now. Okay, thank you. Nothing will move now. All right, yeah, that's what I was afraid of. I can't reset once I'm in there. And then there's another one where it's revolving around. You see how it's revolving? And you're getting these washers down here. You see that? It's not a website. It's an application that we have. Okay, so we're going to stop revolving. All right, so do you kind of get the idea of what's happening here? Okay, so when we are here, if we're revolving, so let's draw one of these. It says find the volume when, all right, so we're going to draw a picture. We have f of x equals the square root of x. So that is a function. You should know what it looks like. Looks kind of like that, right? We're going from 0 to 4. This is 0. We can say 4 is right here. So this is what we're revolving. Okay. We're going to revolve this around the x-axis. So this is my axis of revolution. That shows that you're revolving, right? So when you do that, the first thing you do, and I don't know if y'all, well, geometry was the year of COVID, right? Okay, so then you probably didn't get this far, but one of the activities that I loved doing in geometry was solids of revolution. It was basically creating cones and cylinders and stuff from revolving a triangle or whatever, and then you actually being able to visualize this stuff. I don't know if they still do that in there or not, but so the first thing we do is we reflect that down, right? And then this is going to revolve around, so this is my circle right here. You see how that's, and then you have circles going all the way through, like it's circles all the way down. You see how that works? And because you're revolving, it's going to create a circle every time. It's like your tires spinning. You're creating circular motions here. So this circle right here is a pretty good one for me to, and then I can draw, this is my circle. But remember, it's considered a disc because it has some thickness, right? And our idea is that we get the thickness to be 0, right? So this is just one radius, so that's just little r. Everybody with me so far? And all of these circles, bless you, all of these circles that create this all the way around, we're going to add all those up. We know how to find the area of a circle. It is pi r squared. This is not a semicircle, it's just a circle, right? So the radius is this part right here. Bless you. How do I find the radius? The distance from the x-axis to this. What is this? What is this? Square root of x. This is the square root of x. 4. It's not 4. It's 4 at one point, but that's the square root of x, right? So if whatever the radius, wherever this circle is, that radius is whatever that y value is, which is the square root of x. Which means that your area is equal to pi times the square root of x squared, which is just x. Right? Another way we could have written this up here too is that you can leave the pi in there or you can take it out. It doesn't matter. Volume could be equal to pi times the integral from a to b of r squared dx. That's the same thing, right? But sometimes taking that pi out or taking that constant out, it can just make everything else you're doing make a little bit more sense because so you don't have extra mess in there, right? So when we integrate here, we're integrating the area of all those little discs, right? So my volume is going to be the integral from what to what? 0 to 4. I'm going to put the pi on the outside. I never remember to do that until I've already written it. So pi, and then r squared. What is r squared? X dx. It's just x. R squared is x. Right? So my volume is pi times, well, when I integrate x, what do I get? X squared over 2. Evaluated from 0 to 4. So this is going to give me, when I substitute in my 4, this is going to give me pi times 16 over 2 minus 0. So this is just 8 pi. No, you don't. And you can leave it like this even if it's free response. How do you know it's a disk? That's a very good question. Because if I revolve, if all they gave me was this, and I'm revolving it around the x-axis, the hole, it's touching it. There is no hole there, right? On the next one, we'll have a hole, and you'll see how you know that. It's a very good question. Anything else? Yes, it might say revolved. I think the more proper word is revolve, like these are revolutions, because like when you're rotating, that's more of a two-dimensional thing. Does that make sense? But I guess you'll see both. But yes, it'll tell you that it's rotated. That's how you know to do that. Okie dokie. So now we're going to find the volume when We have the same function, so we're going to go back and just redraw this. So I have square root of x, still going from 0 to 4, wherever 4 might be, right? But this time it's rotated about the line y equals negative 1. Here we are at negative 1. Okay? Yes. So this is that area. And so when I revolve it around that, this is going to end up, this point ends up right here, and it looks like this on this side, right? Basically like that. And so that's just the reflection. I always say just reflect it first, and then we'll go back and revolve it and decide what it's going to look like. And so this is just right here, right? This part right here, if I revolve this, and then I also have this part in here that's happening. That's weird. Because because this is only the area between this and the x-axis, and you're revolving it around this line, so it's coming out like that. Okay? So when there's a space, when there's this space right here between the shaded region and what you're revolving it around, that's when you're going to get the washer. Okay? Make sense so far? We good? So my washer is going to look something like this. Okay. And we have a little r and we have a big R. So let's think about what these two things are. I know. Okay, so this is my little r. This is my big R, right? What is the little r? 1, right? Because this space right here, that's 1. 1 and 1. So little r is 1. Big R. What's just this piece? Stop saying 4, Kylie. Square root of x. Whatever this is a square root of x. And then this is what? 1. The distance is 1. So this is the square root of x plus 1. It's not 4. Huh? 3.5 hours after we start. Mm-hmm. Oh, you'll be fine. Okay, are we all good on how we got everything? Yes? It's not 4. Just remember that, it's not 4. Okay, so now we're going to integrate. We want our volume. We're going to integrate, so I'm going to put my pi out here, and I'm going to integrate from 0 to what, Kylie? 4. You get to say 4 this time. Of r squared, so that's the square root of x, plus 1 squared minus 1 squared dx. All right, any questions on how we set that up? Yes, this is the big R. It's the entire radius of the whole thing. It stops at the line, and then this is the little r. Yes. So since this is 1 unit away, I've got to go 1 unit on the other side. It depends. If this was at -2, it'd be 2 units away. It's going to be, yeah, it's going to be, when you reflect, it's the same amount, whatever it is. You just step that much on the other side. Okay, we good? What questions we got? Okay. So let's go ahead and do this, right? Because sometimes these are calculators, sometimes these are not. So if I square, y'all are turning the page, I ain't turning the page. If I square this, if I square that binomial, am I just going to get x plus 1? No. Oh my God, no I'm not. I'm going to take this right here, I'm going to do math. I get the square root of x plus 1 times the square root of x plus 1. Okay, that's okay. I would get 1 over there, and you're correct. All right, so we're going to FOIL. Square root of x times the square root of x is x. Then I get square root of x plus the square root of x plus 2 square roots of x plus 1. Right? Yeah, minus 1. So that means here I have pi times the integral of from 0 to 4 of x plus 2 square roots of x plus 1 minus 1 dx. So yes, these are going to zero out. So now that leaves me with pi times the integral from 0 to 4 of x plus 2 square roots of x dx. So I want you to integrate that.
X to the 1/2, so it would be x to the 3/2, so it would be 4x square root x over 3. 2 times 2. I said it's 4 square root x over 3.
Okay, so that x to the first, that'll be x squared divided by 2, right? Then plus, so that square root of x is really x to the 1/2, so I add, so this will give me 2 times x to the 3/2, is that correct? And then I multiply that, or I'm sorry, I'm supposed to divide it by 3/2, so I'm going to multiply it by 2/3. So it's okay that you don't put 4/3 at that spot. Do it a piece at a time so you're not making up stuff, right? And we're evaluating from 0 to 4. Okay, so it really is 4/3, and we can use it that way, but well, it's 4/3 x to the 3/2 power. All right, so I'm going to substitute in so I'm going to have pi times this mess that I find. 4 squared is going to be 16 over 2 plus, yeah. Right, so since I have brackets, you can put it on the bracket. Yeah, that's why. That's a good question. All right, so then I'm just going to put my 4/3 there, right? And then I'll figure out what I'm supposed to do with this 3/2 power. That's the same as taking the square root and then cubing it, right? Square root of 4 is 2, cube it, I get 8, right? And then minus 0, right? It's just going to be 0? Yes. So that means I get pi times 8 plus 16 divided by 2. Oh, this 8? Well, while you were talking, I was doing the 4 to the 3/2 power, so I took the square root of 4, then I cubed it. Oh. 8. 8 times 4 is 32 over 3. And then really, this is fine for a safe stop. The only reason you would have to keep going is if it's multiple choice. And then know what you're doing. Okay. So then that'd be 24 over 3, so that'd be 56 pi thirds. You can. I'm just saying if we had to go all the way. Yeah, no, you can. But yes, you can stop. If you're going to stop, stop here. Like if it's not multiple choice, stop here. Totally fine, right? Leave it as 16 over 2. Leave it as, whatever. Even leave it as 2/3 times 2 times 8. That's all fine. Okay, don't mess up because it's some stupid arithmetic something. Okay, we good? All right. So now we're going to find the volume of the solid formed by revolving the region bounded by the functions the square root of x. So we're still using square root of x. So we know what that guy looks like, right? Square root of x squared, which looks something like this, So this is our region. And we're revolving it about the line y equals -2. Hey. Oh, you're amazing. Thank you so much. All right. Okay, thanks. No, this is for after school. Okay. Y equals -2, right? Everybody with me? Okay, so the first thing we're going to do, since we're revolving it around this line, is we're going to reflect it. Since this is 2 away, we go 2 away on this side. And then we just, stop saying huh after literally every single thing I say. So it's just something like this. That's too big, but you get the idea. It's kind of the same shape, right? Okay, so we're going to have a washer that goes from here. That's the inside circle. This is the outside. Oh, no. This is the outside circle. Pretty much.
Looks at this and says, oh yeah, it's a washer.
There's applications to it, I promise. Okay, so we have this washer here. We'll look at them. We just got to get there first. Okay, this right here is your little r. This right here. Where do we start? Like, where does this touch? What is it? It's touching this one. It's touching x squared. So maybe it would be better if I started over here because you can't really see if there's anything there. But that distance there is whatever x squared is when we substitute it in, right? And then what do we have to add to it? 2. So it's not really a -2 because it's a distance, right? So this is the square root of x. So our little r is x squared plus 2. Everybody okay with that? All right, so our big R goes from here to here. Yes, so big R is the square root of x plus 2. Okay, so the other thing we have to figure out are our limits of integration. We have that we know we start at 0, but we don't know what the b is. So our a is 0, basically. We don't know what b is. So we got to figure out where they intersect. So I have to take the square root of x and set it equal to x squared, right? So can we square both sides? And I get x equals x to the 4th. So x to the 4th minus x equals 0. I got x cubed minus 1. So that's 0 and what? 0 and 1. Okay, so this is at 1. So my volume is pi times the integral from 0 to 1 of big R, which is the square root of x plus 2 squared, minus little r, which is x squared plus 2 squared dx. What? Say that again? Because it's pi r squared. Okay. There you go. Are we good? So we're not going to actually integrate that because I want you to have some time. But any questions about where anything came from? My picture is horrible, okay? But I got it good enough to where I can think through what's what, okay, as far as the radius and stuff is concerned. Are we good? All right, so now we're going to do a vertical one here. So it's just, you got to draw it so you can make sense of it. Come on. I don't know, that orange piece, I guess, is not going away. All right, find the volume of this solid formed by, okay, so now we have square root of x squared. We've already done this, so we kind of already know what's happening, right? We know that this is at 1. And this, I'm supposed to revolve it around the line x equals 2, which is this line right here. Oh, no. I know, I had to extend mine too. So the first thing we're going to do, just like on the other ones, this is going to be a 3 here. I'm just going to kind of, it's good enough. Gets me the idea so I can figure out what the heck's going on with the washer. All right? I just reflected this across that line. That's all I did. Well, mine goes past. That's fine. All I really need to know is if that's at 3. And then so I have this, which means here's the inside, and here's the outside, like so. Yes, so since it's about the line x equals 2, that means this is going to be a dy situation. So I have y equals the square root of x. I need to square both sides, so I get x equals y squared. That's what this one is. And then I have y equals x squared. So I take the square root of both sides, and I get the square root of y is equal to x. Now it's technically plus or minus x, but all I have is the positive part of it. So that's good. And that's what that is over there. Okay? And then this is, oh, I did that wrong. That's not that one. This one is the square root of y equals x. This one is the x equals y squared, because it came from the square root. So let's draw our washer. This time the washer is going this way, right? That's how it's revolving. So my little r is from here to here. From here to here. The little r is this part right here. So this little r, remember we're going to the y-axis here. This is going to be 2, and then I have to subtract out the rest of that, and the rest of that is the square root of y. So this is just 2 minus the square root of y. Big R is going from here all the way to here. Oh my goodness. Big R is right here. So that's going to be 2 minus y squared. The other thing I need to figure out are my limits of integration. I'm revolving around this way, so I've got to go from 0 to whatever this is, right? So I need to set these two each equal to each other. So y squared equals the square root of y. So y to the 4th equals y. And then it ends up being the same kind of thing that we did on the x. So that means we're going to 1 again. Any questions on where anything came from? Okay, so now we need the volume, right? Volume is pi times the integral from 0 to 1 of big R, which is 2 minus y squared, minus little r, which is 2 minus the square root of y squared, and then that's dy. Well, you're not getting credit for your drawings. You need to draw it for yourself so you can wrap your mind around what's happening, right? That's the important part of that there. All right, what questions we got? Anything? That's a statement, not a question, and you just need to practice and we'll be okay. Oh. I have no idea. Sorry, I don't know those kind of questions. I don't know those kind of answers. I wish I did. I have no idea. Okay, and this is one of those weird lines that I don't even know how it happened, but it won't go away, so we're just going to pretend like it's not there. Okay. Actually, I want to skip. I don't even want to do this one. I just want you to start practicing these on your own. Okay? Sketch them, see what you can figure out. You got this.